All right. Geometry, Chapter 6, Section 6. Trapezoids and Kites. Okay. Definition heavy again. Uh, we have a trapezoid. All right, trapezoid is a quadrilateral that has exactly one pair and only one pair of parallel sides. Meaning, it is not a parallelogram. Not a parallelogram. So we've been dealing with a lot of parallelograms and parallelogram rules. The rules of a trapezoid, it is different. These two are not parallelograms. Okay? Trapezoid is a quadrilateral with exactly one pair of parallel sides. When we draw a trapezoid, this pair of parallel sides, just the one pair, these guys are called the base. The base. Anything that's not a base, that are not parallel, they are called the legs. The legs. Okay. Uh, these angles here, they are called the base angles. Base angles. All right, because those angles touch the base. And there's four base angles. Two for the top base, two for the bottom base. All right, or you could say that they have two pairs of base angles. Uh, the two angles that touch the top base are those base angles. The two angles that touch the bottom base are those base angles. All right? So that is the vernacular for a trapezoid. Then we have a unique type of trapezoid called the isosceles trapezoid. It's a trap. It's isosceles trapezoid. We have a trapezoid. Again, a pair of parallel sides, which makes it the base. But now, for something to be an isosceles trapezoid, the legs have to be congruent. So it's still a quadrilateral, right? Still has exactly one pair of parallel sides. It's still not a parallelogram. Now it has the legs are congruent. Okay, the legs are congruent. Isosceles trapezoids, the legs are congruent. Which leads us to Theorem 619. And what Theorem 619 says is that if we have an isosceles trapezoid, if it's an isosceles trapezoid, then the base angles are congruent. Remember, this is not a parallelogram. The base angles are congruent. So the rules for the angles are going to be different. So this angle is congruent to that angle. and this angle is congruent to that angle. The base angles are congruent. So just to call this, it looks like a 90 degree. The book says RTAP. It's a trap. That's cute. Then we could say that angle R is congruent to angle A, and angle T is congruent to angle P. Theorem 619. So over here, they give me a isosceles trapezoid. I know that these two guys are the same. Q, P, R, S, which means these guys are parallel. And they give me angle R is 106. So they want to know what the other angles are. Well, since I know that base angles are the same, I know that 106 and, or angle R rather, is congruent to angle S, since they're base angles and they're congruent to each other. So I could say that angle 106, or angle S is equal to 106 degrees. Alright, these guys are still parallel lines, right? If they're parallel lines, this is going to be my transversal, which makes Q and R same side interior angles, or consecutive interior, and angle P and S are consecutive interior as well. So, angle Q plus angle R, they're supplementary, right? Consecutive angles. And angle P plus angle S are supplementary. My transversal, here's my two parallel lines, which means that I subtract 180 minus 106, which gives me 74 degrees. So angle Q, which is equal to the measure of angle P, because they are base angles, they're 74 degrees. Alright. So this problem here says we have a fan that has two 15, like your problem 2 that has 15 angles meet at the center. So we have the center of my thing, and I have, in this case, it's 15 of these things. Since I have 15, I know that it creates a circle. A circle is 360 degrees, so I'm going to divide that. This is going to be angle 1. I'm going to divide that 360 by the number of triangles that I have. So one circle is 360 degrees, or one revolution, to go around one time. I divide it by the number of triangles that I have, which is 15, and I get the angle of measure of angle 1, which is 24 degrees. Okay. So 24 degrees. So I can think of this as a triangle. This is 24. If I draw a line from here to here, I know that this guy is parallel to this guy. Then I have a trapezoid, which will make these guys base angles. And I know that base angles are congruent. They're the same. So I could call that X, and I can call that X. knowing that I have an isosceles trapezoid. Uh, so then I can say that um, all three sides of these, right, due to the triangle sum theorem, 24 plus x, since they form the angles inside of a triangle, are supplementary. They add up to 180. And I can say 2x equal, or 2x plus 24 equals 180. Subtract that from both sides. 2x equals 116. X equals 58. 58. So x equals 58. But they don't want 58. They want the measurement of the obtuse angle of the isosceles trapezoid, which would be that guy. This is not obtuse. So in order to find out what that is, I know that since this is a parallel line, and these are parallel lines, these are the parallel lines right here. So these are the parallel lines, which would make this my transversal. Jeez Louise. That's my transversal. So that would make those guys. So did you guys see better? That would make these guys same side interior or consecutive interior. So once I find what x is, I can say, okay, x plus y equals 180 degrees because they're supplementary. So x, which is 58, plus y equals 180. So let's subtract 58 from both sides. And I get that the obtuse angle of the trapezoid is 122 degrees. It's a good problem. Okay. Theorem 620, if I have an isosceles, if I have an isosceles triangle, then its diagonals are congruent. So if I have an isosceles triangle, A, B, C, D, right? Meaning these guys are parallel, these guys are congruent. When I draw my diagonals, A to C, B to D, and I know that if A isosceles trapezoid, then AC is congruent to BD. The diagonals are congruent. Okay. Isosceles trapezoid, or any trapezoid, has something called the midsegment. And if you recall, the midsegment, we've learned this in when we did midsegments of triangles way back when. The midsegment joins the midsegments of the midpoints of the legs. Joins the midpoint of the legs, and it has two quote-unquote unique properties. So it joins the midpoints of the legs. So if I was to draw a trapezoid, got RTAP. And I have the mid segment. So the mid segment's going to cut the legs in half. It joins at the midpoint. So this guy and this guy is going to be the same. And this guy and this guy is going to be the same. So this is point M and N. It does two things. This is the mid-segment theorem, or trapezoid mid-segment theorem. Alright, so the trapezoid mid-segment theorem says that if a trapezoid, if it's a quadrilateral, or if a quadrilateral is a trapezoid, then two things. Thing number one. This guy, remember a trapezoid says the bases are parallel. Well, the mid-segment would also be parallel to the bases. The mid-segment will be parallel to the bases. So MN is going to be parallel to RA, and MN is going to be parallel to TP. They're going to be parallel to both the bases. Okay. In addition to that, the mid-segment is going to be half the length of the sum of the bases. So if I was to find out what the distance of MN is going to be, it's going to be half the distance of the sum of the bases. So if I add TP, the base at the bottom, plus RA, the base at the top, and I divide it by 2, that's going to give me the length of the mid-segment MN. So two properties. If the quadrilateral is a trapezoid, then the mid-segment MN is parallel to both the bases, RA, and MN is parallel to TP, and the mid-segment MN is going to be equal to half of the sum of the bases, half of TP plus RA. Right. Knowing that information, you can do some stuff. Okay. Stuff number one. Oh, cool. I'll just keep the numbers that they have. How convenient. They tell me, oh no, it's not the same. Man. Playing with my emotions. Alright, so we have Q, ARA, P, and S. I have 10 up here. I have 2x plus 11 here, and I have 8x minus 12 here. They want to find out what is x, then they want to find out what the length of the mid-segment is. So, part 1. Since I know that Mn is equal to 1/2 the sum of QR and PS, I will substitute. So Mn is 2x plus 11. That's equal to 1/2 of 10 plus 8x minus 12, which is 1/2 of 8x minus 2, which is 8 divided by 2 is 4, minus 1. So 4x minus 1. So 2x equals 4x minus 1. Add 2x plus 11. I'm going to subtract 2x from both sides. So I have 11 equals 2x minus 1. Add 1 to both sides. 12 equals 2x. Divide by 2x equals 6. Then they want to find out what mn is. We know that x equals 6, so it's going to be 2 times 6 plus 11. 2 times 6 is 12 plus 11, so that equals 23. Okay. X equals 6, mn equals 23. Alright, then we have a kite. Kite is really not a parallelogram. There are no parallel sides in a kite. I repeat, no parallel sides at all in a kite. Theorem 622 says if a quadrilateral is a kite, then, oh wait, we're skipping, on my fault. What is a kite? Alright, so if we have a kite, kite is a quadrilateral where we have two pairs of consecutive sides that are congruent. Alright, quadrilateral with two pairs of consecutive sides. That's the key. Remember, consecutive is side by side. They touch, they connect to each other. No opposite sides are congruent. Okay? So if I get a kite, haya, haya, these two guys touch each other. Now, haya, haya. Let's do it a little bit. Haya, there we go. Haya. Actually, it looks like a kite. These two guys are consecutive and they touch, they're congruent. These two guys are consecutive because they touch, they are congruent. They are not opposite sides, they are consecutive sides. They touch each other, they are congruent. This is a kite. I repeat, this is a kite. Consecutive, two pairs of consecutive sides that are congruent. They touch each other and they're congruent. Not opposite sides. I repeat, not opposite sides. Which leads us to theorem 622. Which said if it's a kite, then the diagonals are congruent. So if we have A, C, B, and D, A, B, C, D. Alright, if it's a kite, then AB is perpendicular to BAC, I'm sorry, is perpendicular to BD. So I draw a diagonal, A to C. Draw another diagonal from B to D. Those guys are perpendicular. Right? Alright, so if we have a situation here, draw a kite. Sheesh. Yeah, I feel better with that one. All right. They give us that this angle is 36. They want us to find angle 1. They want us to find angle 2. They want us to find angle 3. Okay. First thing I know, that if it's a kite, then I know that this is perpendicular. So that's 90, that's 90, that's 90, that's 90. They're all perpendicular. So then I know that angle 1 is 90 degrees. So if angle 1's 90, then this guy over here is 90. Remember, if something is a perpendicular bisector, it cuts the angle in half. Definition of a angle bisector, right? Here's our ray. No. Yeah, this cuts it in half. So if this is 36, then the angle number 3 is also 36. Because it's a perpendicular bisector, this is cut in half, and it also cuts the angle in half. So angle 3 is 36. So then to find angle 2, it's a triangle, they're supplementary, so to measure angle 1, measure angle 2, measure angle 3 equals 180. So 90 plus the measure of angle 2 plus 36 equals 180. That's 126. Subtract 126 from both sides, so measure of angle 2 equals 54 degrees. So angle 3 is 56, angle 1 is 90, and 36. And then the measure of angle 2 is 54. Okay. All right. Our quadrilateral family. We start off with a quadrilateral, which is just 4 sides. You get to the right, we have all the parallel sides, pair of parallel sides. So we have parallelogram, which gives birth to the rectangle and the rhombus. Rhombus and rectangle gets together and give birth to the square. We have a quadrilateral. Only one pair of parallel sides gives birth to the trapezoid, and then a special trapezoid is the isosceles trapezoid. And then we have consecutive sides that are congruent, no parallel sides at all, and we have a kite over here. The quadrilateral family. All right, that's this section. Hope you have a great rest of your day.